Cannot hear you. You're
Yes.
muted. Okay.
Then recording. Yes.
Okay, perfect.
I was also trying to save the presentation in the project repository.
Yeah, maybe maybe a good thing to also circulate the presentation after the meeting. Yeah.
Yeah, but just in case there are issues with the connection. Okay.
Okay, so I think we can start if you're ready. So good afternoon, everybody, and welcome to this joint Accordion charity meeting. My name is Emanuele Carlini. For those who don't know me, I am the coordinator of Accordion, and I'm very happy about this joint webinar because it merges two projects that not only share several people and organization, often people in both consortia, but also the consortia, the project, they share the same, I would say, technological and scientific view, right? So I would say, there's already a good degree of collaboration between two projects, and this webinar is a way to reinforce our collaboration and for the good of both projects, but also for the good of the audience that hopefully will listen interesting topics and idea today. Our speakers will be in order. Massimo Coppola from the Accordion Consortium. Massimo will speak about the accordion project, the orchestration in the accordion project, and also how the use cases in the accordion would benefit from the orchestration. The second speaker would be Ferran Diego from the Charity Consortium that is explaining us a little bit of charity and how the edge computing is beneficial for XR application, which are very demanding in terms of interactivity and and then can benefit a lot from edge computing. And also it will provide some algorithmic insight about this topic. So Massimo, the stage is yours, and please go ahead with your presentation.
Yes. That should be working. Can you see the screen?
Yes, we can see.
Okay. So, trying to no idea what's happening with the no.
Massimo, you are on hold.
Do you hear me?
Yes.
Yes.
I don't know what happened. I lost completely the meeting. I'm trying again. Okay. I presume you see my screen. Okay.
Yes, I
So-
can see it. Yes.
Good afternoon. Sorry for the mishap. So good afternoon, everyone. I'm Massimo Coppola from ISTI CNR, and I'm a scientific manager from Accordion, and publication manager. I'm going to present the Accordion approach to managing application in the cloud and in the continuum. And this is a very good occasion for us to show that projects like Accordion, Charity, and more can collaborate and solve the big problems that we face in the continuum computing field by developing tools, technologies, and methods that can work together, can extend each other, and cooperate toward a common goal. So the Accordion Consortium, many of the people listening today will probably know already, is composed of several partners from different countries of Europe, with a very broad and detailed and complementary, in some cases, set of competencies about cloud computing, about service computing, about exploitation of GPUs and CPUs or server computing. There are partners with experience as internet providers or collaboration with internet providers, with the ecosystem, experience with the ecosystem of the user devices. And the Accordion ecosystem is designed in such a way to exploit this set of competencies and expertise. So what are the goals? Well, cloud computing has been thought for many years as a modern revolution, fulfilling what was the long-lasting dream of providing computing as a utility, just like we have water, energy, gas, and so on. Of course, recent events may have reminded us that not always gas, energy, and whatever can be taken for granted in an absolute sense. But the idea is that utility computing was something that we should be able, we thought we should be able to deliver to the user on a by-need basis with an infrastructure which can adapt to the needs of the users and their sorry, something not working with the slide. Adapt to the user and their varying needs depending on the activities and necessities of the end users. So in providing these dream, let's say, in trying to fulfilling this dream of utility computing, we have lost something or someone behind, because there is a class of application, the ones that are often called next generation application, which not only need computing power per se, but they need computing power under a specific set of constraints with specific needs, which include the low latency, may include the high bandwidth, may include constraints on data movement, may include high sparseness and high dispersion of the computation across a large set of users, and so on. So there are uses where the adoption of a continuum platform of edge computing as a component, a significant component of the computing platform, in addition to the cloud, is an opportunity to address this kind of new next generation application. Edge in particular is an opportunity because it has several advantages from the technological viewpoint and also from the economic viewpoint. The edge devices are pervasive. They allow for a large amount of heterogeneity and different situation. And of course, the fact that the edge is so heterogeneous and pervasive, to some extent, limits the lock-in effect that we may have in different situations. We should of course, be aware that these can be seen as advantages of the edge computing layer can and usually are also the limits that we find when we try to exploit this computing layer. From the economic viewpoint, of course, having a large scattered dispersed platform which we can leverage is in a sense an antidote to the movement of all our data and computation toward big cloud companies. It is an opportunity for increasing the development of small medium enterprises, especially important for Europe. And again, from an economic viewpoint, this is a push toward the exploitation of federations, federation of providers of computation, and federation of provider of services and application. So there is definitely a strong interest in exploiting this edge layer together with the computing resources that are typical of the cloud. Well, the Accordion project tries to support the enlargement of this infrastructure pool that we have to include edge resources and several different kind and typologies of edge resources in order to have an increased coverage from the geographic point of view of users and enabling application which can be ubiquitous, can be collaborative, and in doing this, exploit these edge resources. Now, in Accordion, we have this approach that everything is an edge resource. So we try to extend the infrastructure pool with all kind of available network and computation resources. Those provided by telco operator, those provided by big cloud data centers, so cloud providers, those which are in the hands of the end user, and those which are located scattered geographically among the network and are possibly owned by different stakeholders in such a way that we have our first choices for deploying computation or for offloading computation. We have the first choice in nearby services, nearby hardware, nearby resources. And we leave the use of the public cloud, which provides the equivalent of an infinite amount of resources. We leave this exploitation of the public cloud as a last resort or devoted to those cases when the huge amount of computational power and storage provided by the cloud, it is really needed by the user. The other idea that is underlying the Accordion approach is that by exploiting a large amount of edge resources which are closer to the user, we are also more able to manage the fluctuation of the resources due to the changing situation of the computing and storage and network resources themselves, or to the fluctuating needs of the users. So the infrastructure pool, sorry, there is an error in the slide, is going to be a pool of resources which enjoy low latency properties because they are close to the user, which are volatile because, of course, these are not large data centers which enjoy backups, redundancy, or whatever. So they are volatile, they are dispersed, and of course they are highly heterogeneous. So we need to provide suitable abstraction, suitable technologies to exploit these resources, hiding their heterogeneity, their volatility as much as possible to the user and to the application developer as well. The computational capacity overall will be fluctuating as well as the network performance. So we need to efficiently manage such pool, developing additional technology, developing new technology, which makes us able to monitor, to detect these variations, and to ultimately manage the platform in spite of this high degree of variability and actually exploiting the set of resources despite the fluctuations. Okay, I think these. Well, that's what I was saying before. Sorry, I did not underline well in the previous slide. The point is that we are not only providing these in order to assist the end user. In order to reach the end user, we need to assist application providers, application developers, and so we provide data services supporting this application, which enable this application to share data, to monitor the platform, to exploit the platform in a careful and in an optimum way, despite these fluctuations. One of the activities that, of course, are needed is the ability to migrate instances of application within the Accordion Continuum platform in order to exploit better conditions from the resources and avoid being tied to resources which, as we said, are volatile. Within the project, can you still see the slide? Okay. Within the project, there are several use cases. I will be very quick about those demonstrators in order not to get into the details because there would be a very long discussion. But these demonstrators are actually focusing on the kind of next-gen application that, the kind of next-gen application that actually exploit the Accordion provided features. So we have a first use case, which is a collaborative virtual reality. It is actually a platform for creating virtual reality medical scenarios, which are used as a collaborative experience in order to train, in order to make people experience situations which are remote or which are used for training without having the need for practically creating this training environment, or with the option to share the training in a much easier way among the target users. Of course, beside being a collaborative experience, clearly this virtual reality use case requires a lot of technology about the geometrical manipulation of this virtual world and needs support in order to reduce the development time for this kind of application. If we are going to use them for extensive training, in this case of a clinician, but in other cases of other professional figures, of course, we cannot afford to have a platform which forces us to spend a lot of time in developing, targeting the different devices and the hardware. We need to allow the application developer to focus on the VR experience without having to worry about how the set of resources in the edge and in the cloud are exploited. So in this context, there have been used several standards inside the use cases in order to increase the battery life of mobile devices, for instance, or to increase the experience, the quality experience of mobile user or user which are connected via Wi-Fi. Of course, rendering a virtual world is a difficult task, is a demanding task, and in some cases it is important to be able to allow to dynamically allocate resources for this rendering and for the manipulation of the virtual world onto devices which are close to the user, because we need low latency, but independent from the actual user device, so they can provide more memory, more computational power, differentiated acceleration capabilities. So this is a use case which requires subtle and detailed control on the resources which are actually used as a proxy toward the user, in order to guarantee that the quality of experience and the quality of service of this interactive application stays high. Another use case that we have in Accordion is a multiplayer mobile game where a population of gamers collaborate and interact with each other on a large platform. And a huge number of players, up to 100 in the case of this use case, can interact with a single server, where several servers then interact with one another, and which are spread on the Accordion Federation. And so we have several levels in these use cases where we exploit AI, because we need to govern and possibly migrate or replicate the server, which serves a number of players. But also we have to work out an allocation of the whole set of servers, which is able to follow the global set of users, which is able to serve them with suitable latency, suitable bandwidth, and suitable computation time, in order to avoid that any of them, due to the geographic distribution of the game servers, is actually enjoying a degraded experience. There is also another use case. I'm not going into detail of all the use cases. If you have a question, of course, after the presentation, I will try to answer, but there are a lot of people from Accordion which may help in this. So another application that we have as a use case in Accordion is the one about advanced digital marketing, exploiting the mobility of users, exploiting intelligence, and exploiting the spatial distribution of users in such a way to identify the person as it moves around in an environment, identifying the person by its mobile device identification, and making choices about what content to show to the target of the advertising. So decision about the content, a decision about the type and format of information that we want to show, different choices of broadcasting depending on the actual device that we know we have clear to the user. Another application which is related is that of mobile games which exploit augmented reality. So again, you have the need to adapt your application, and so the resources used by this application, to the spatial distribution of the user, which are typically going around minding their own business or enjoying the game. And so you need to support a multiplayer application, which is used as a form of marketing, but nevertheless needs to deal with detecting user in real space, manipulating geometric 3D objects, adapting the game scenario depending to the user location or activity, and so on. So we have, again, a set of requirements for the Accordion application from its main focus, which is developing the application, which has a huge set of constraints per se, which do not depend strictly on the exploitation of the platform. Okay, so how do we plan to achieve such a goal in Accordion? Well, the overall goal has been split in several different activities and direction. One is the choice to have an application model, an application high-level way, and a way of describing the application with a high-level formal specification, which can be adapted both to the cloud and to the edge, or to the cloud and edge at the same time in the actual realization of a continuum platform. Clearly, the cloud continuum needs to be provided, needs to be reached via API, which guarantee some degree of dependability, which can guarantee security, and guarantee the opportunity to dynamically manage resources and dynamically access the needed resources to the application. This in turn implies that we have to have resource management, which is able to manage all of these different kind and typologies of resources dynamically and efficiently. These more or less calls for advanced techniques of machine learning, of AI, in order to detect the resources and the application behavior, and make sure that we do not only match the current needs of an application with the current availability of the platform, which is already a complex issue, but we also try to forecast the requirements of the application in the future, and we also as much as possible, try to forecast the behavior of the platform in the future, and we try to match this future behavior with each other. So in order to minimize the overhead that we have in managing such a dynamic situation. Clearly, orchestration is one of the more complex feature in this kind of situation, and still needs to be done quite efficiently. The overall approach of Accordion has to rely, in order to achieve a good trade-off between the ability to manage complex problem of orchestration and resource management, and the need to do this efficiently, quickly, with not a lot of overhead. The obvious choice is to have a multi-level approach, which works for the orchestration and also works for other issues, which are data privacy, preservation, and data management with minimal overhead. This is the Accordion conceptual architecture. As you see, we have several layers in this overall platform. The combination of those is thought as to provide the security, privacy, and automation to application developer in DevOps style, I mean. Clearly, in this view, the application developer, the next-gen developer, is on top of the platform and works with an abstract view of the kind of resources that the application can provide. And we are developing in Accordion a management framework in order to support the developer. Then we have several layers. The lowest one is the physical one of the, I don't know if you see the pointer. The lowest one is actually the layer of the actual edge resources where physical devices are found, where we can have commodity computers, we can have mobile devices, we can have embedded systems, we can have a small single board computer, or a small cluster which are located in a specific geographic situation or in a specific environment because of the stakeholder constraints on these kind of devices. Of course, as we have seen, it is relevant for our use case. In this layer, you can also find the integration with augmented reality device, virtual reality device, and any kind of display which we can provide to the user in order to make it experience an augmented virtual world. In the same layer, beside the physical set of edge resources, which are scattered among a huge number of sites in our typical scenario. Of course, we also have the resources in public clouds, which means whenever we need additional computational support, we need additional computational power, we are able to rent resources from cloud providers. Of course, on top of this layer, there is the layer of the network, which means that we can, to some extent, think of controlling the functionality of the network via SDN-like capabilities or allocation in the network. This is not strongly explored, as far as I know, in Accordion, but it is part of the design. The greatest part of the contribution in current Accordion development is the one which focuses on the actual sharing, management, lending, offloading of computation to resources. And it is quite important to notice that all of these resources are, beside generally saying heterogeneous, can be accessed in different ways, via virtual machine, via container. Within Accordion, there is also an activity in studying and investigating about the exploitation of unikernels in order to have the deployment of activities on power-constrained, energy-constrained, feature-constrained devices, which are typically found on the edge, with the minimal overhead possible. So exploiting the fact that unikernel typically gets rid of most of the overhead implied by a general purpose operating system by splicing and cutting away all the function that the specific application we want to execute does not need from the kernel of the operating system, and thus realizes very low overhead container or VM to be run on constrained resources devices. Then, of course, we have the general infrastructure which allows us to deploy container, deploy virtual machine on different kind of devices. And of course, there is also here some attention that we need to perform, because part of the heterogeneity of this platform lies in the fact that we have different kind of architectures supported in the cloud and edge devices, and even among architecture which more or less belong to the same world, let's say ARM architectures, there are actually a lot of different versions supporting or not 52 or 64 bits computation, different choices of operating system, different subset of the CPU instruction, different kind of libraries, and so on. So there is a lot of heterogeneity which needs to be taken under control, and which needs to be confronted when we want to confront the situation of deploying part of an application without knowing in advance what kind of a device, a computing device, will accept the task of executing this. Here at the level of the computations, we have the abstraction of mini clouds, which I'm going to talk in a minute about. And on top of this, we have a further level of orchestration, where orchestration here means trying to deploy application or parts of application by choosing if they are going to be on public clouds, on edge devices, on aggregation of edge devices, which we call mini clouds, and being able to make this high-level orchestration in order to exploit group of resources, which are then managed by a further level of orchestration. So we try to provide a solution to the continuum exploitation, which is, let's say, holistic, in the sense that tries to take into account all the aspects of the problem. Of course, not all of them can be developed to the same degree of maturity in the course of a project, which is actually in this moment a little bit more than 3 years, because it's 3 years plus something. The organization of the work, which has been established in Accordion, is to have these 3 frameworks, one on top of the other, that work on different layers of the physical architecture that we have discussed, and provide all together an integrated solution for developing, running, deploying application on top of such a complex platform. So we have an application management framework, which allows the developer to actually create and control application. We have an edge cloud continuum management framework, which tries to tie together application and group of resources which we find in the platform, and an edge infrastructure pool framework, which is actually the one controlling this group of resources. Try to speed up because I see I'm late. So the edge infrastructure pool framework is basically what provides the abstraction of an edge mini cloud virtual infrastructure manager. So it focuses on lightweight virtualization as much as possible, or component deployment. It provides some storage infrastructure in a coherent way to groups of edge resources in such a way that it can be used for caching, for sharing the data locally. Provides resource characterization and monitoring, because these small set of edge resources which we want to exploit for bigger application needs to be characterized. We need to know what is inside the box for any specific set of edge resources in order to connect them to the cloud. And we need to monitor their behavior, because of course, as we said before, the behavior, physical location, power constraints, user request on these edge devices is continuously dynamically varying. So we need monitoring as an essential part of getting a hold on our physical platform of resources. And so for this, of course, we have a further kind of services on top of these sets of resources which are the mini cloud, which are basically resource indexing and discovery, which provide a tie-in toward the cloud in order to quickly, efficiently discover resources which match the application specific requirements at a certain moment and match a specific condition of availability at the certain moment. I'm trying to go to the next slide. I assume the presentation is still working. Okay. Okay, now we are on the next slide. So the Edge Cloud Continuum Management Framework is the middle layer that connects together all these group of edge devices managed as mini clouds or VIM. There is clearly the need of a further level of orchestration where we accept application and try to identify the resources for them. And these resources are typically found either on smaller aggregation of resources provided by mini clouds or by renting resources from public cloud providers. There are, of course, several aspects that we need to take into account when orchestrating and managing resources at this level. One is the aspect of trying to provide resilient execution, that is detecting when the resources are not matching the expected behavior and be able to migrate part of the application or the whole application to safer resources, to more resilient resources. Secure execution, because all of these connection between parts of the application and data that we want to manage needs to be secured, needs to be protected from interaction in order to avoid both intentional damage or non-intentional damage to the application and its user because of interference with the application behavior, and also to avoid that this data can be exfiltered, that can be read and stole without the application of the platform intervening. So a lot of constraints on security, on secure interaction between different parts of the platform, and also a good degree of attention to operations which are privacy preserving by nature, just like, for instance, constraints about moving data around from one device to the other, needs to be taken into account in this level. Finally, there is an application management framework. As we said, we have to provide a set of features which assist the user in developing the application and providing with a good set of APIs which target the basic needs of any application developer. So providing an application model in such a way that the developer does not need to take care of the low-level mechanism for exploiting resources. The application model can be used as a way to instruct the framework, the application framework, to locate automatically the resources needed. Of course, quality of experience assessment is also a key point from this point, key feature from this point of view. And clearly, if we want to simplify the work of the application developer, DevOps support for network and resource management needs to be one of the issues that we confront. So these all together makes up what we call an application development toolkit for next-gen application. So how do we address the high-level goals? Okay, I'm not going into the structure of the administrative structure of the project, but just to say that these three layers that we have identified so far are a coincidence with three different work packages inside the project. And the output of these work packages, of course, is a set of tools, of software artifact and protocols and conventions to follow when deploying the infrastructure mechanism that allow us to set up the application management framework, the Edge Cloud Continuum Management, which builds up an accordion federation, basically, and all the tools and technologies will need to be deployed on each different set or each different single edge device in order to integrate them into mini cloud, integrate those mini cloud into the infrastructure pool that Accordion manages. Again, problems in switching slide. Okay. The Accordion implementation methodology has been to have 2 full development cycle and one consolidation cycle at the end of the project. I think right now we are near the end of the second full development stint, and the integration of these of the results produced in the project has been accomplished in 2 different phases. The first one, which has been already realized some months ago for the core set of functionalities, and then after some feedback from use case and other additions, a second integration phase, which is going to take place in the next months. Now, I want to spend a couple of minutes more. Let me know if I'm going too long with the presentation about service orchestration. We have several requirements in the project, which should be already obvious from discussion so far. So we have the need to orchestrate virtual machine and containers, and also unikernels, as I said before. So we need the universal mechanism for deployment. It is important to notice that the requirements for the orchestration are different according to different platform layers. So there is most probably efficiency or short service time on edge devices, and the requirements are more focusing on performance, on throughput, when we move to resources in the cloud layer. The orchestration implementation needs to consider a lot of use cases and a huge amount of resource profiles, because basically the type of architecture, the amount of memory, the type of kernel, the type of accelerators, there are a huge number of features that edge resources can differ in from one to the other. So a lot of the orchestration activities are tied to our capability of gathering information about the features that we have in the collection of resources inside our platform. So our orchestration will take into account these insights from the platform and hints and constraints and desiderata from the application, and merge them together, plus managing events if we want to manage dynamically changing situation. Of course, these orchestration features, these orchestration requirements can be different if we look at different projects and different stakeholders. Accordion is trying to be open with expertise. Of course, the use cases in Accordion are well defined, but we have been looking at how different projects like Charity itself, that we are discussing in a few minutes, or for instance, the teaching project or other stakeholders in the industry can have in different situations. For instance, the fact that if your edge devices are all vehicles, so they are all mobile, probably there's not a lot of orchestration you can do on this end layer. I'm not going to detail this because I'm too long, but this was just to underline that Accordion tries to be generic, but different projects, different set of stakeholders can provide other requirements which require interpretation in the Accordion architecture for orchestration and resource management. Okay. What we are doing right now is we are in the middle, actually near the end of developing this new platform with the platform as a service model in mind. The orchestration in Accordion tries to decrease latency between the closed nodes and tries to increase communication speed between first level nodes and end nodes. As we will see later, there may be more stringent constraints for other types of application. We try to use machine learning techniques as much as possible in order to detect the behavior of resources and applications, learning from high volume data scenarios or learn from the behavior of streaming application and so on. We try to learn and gather insights about resources, about storage and networks, and also ultimately from apps. The orchestrator in Accordion is logically viewed as a centralized component situated in the layer which ties together all the platform, and has in principle a global vision of the resources of the whole federation, and can know the position of all the application components and interact with them. The abstract vision of the federation group of resources is basically modeled through a representation graph, where every cloud set of resources or edge set of resources is represented by a vertex of the graph with proper annotation about the type and constraints of the resources which are there, constraints of the network to reach there, and so on. Logical networks are between the different part of the platform are seen as the edges of the graph. So we have these labeled with their expected behavior, in principle with some reserved capability of the network if we have the SDN software not enabled to do this kind of reservation. Annotated with latency, with aggregated bandwidth estimation if we don't have strict control over the network link. The dynamic orchestrator that we are exploiting in Accordion is prototype for the intelligent orchestrator that we have at the moment. Has several inputs, the intermediate application model of the application, which is realized as an extension of the Tosca model. Tosca is a standard for describing cloud application, which has a strong support for extension dedicated to custom exploitation of the standard. We exploit one such of extension. We define it in order to have an intermediate application model that we can exploit in allocating the resources. The operation to be executed, of course, we can ask the orchestrator to allocate, deallocate, reallocate an application of a set or a set of application component, and of course criteria which are relevant for the application developer in order to optimize the deployment of the different components of the application. As output, the orchestrator provides a set of configuration files, in this case for K3S, but I think the mechanism is quite general, which are used to deploy and undeploy a set of components, which are then submitted to the edge mini cloud, that is the sets of cloud resources on the lower layer of the application, or of course to cloud resources if the component is running inside the provider, a public provider cloud. There is, of course, interaction with several of the services which are deployed in Accordion, the resource indexing and discovery services. As I said before, we need to manage resources which are dynamically changing. So we need to index them, discover them, and then monitor them for behavior. Of course, we have a communication with a gateway toward the mini clouds, which is the Vim gateway. And also we have a mechanism for accepting new set of edge resources inside our platform. So there is a mini cloud membership management mechanism, which tries to retrieve metrics from the different edge mini cloud in order to understand how to place them inside the platform. The orchestrator itself exploits at the moment a multi-resource, multi-objective solver. So basically the allocation problem of the application is turned into MRMO problem formulated for the solver we use in the orchestrator, and the problem is solved with standard mechanism, returning us the desired output, desired application configuration, which is then translated into actual DevOps style operation to be executed on the platform. This is a very quick view of the structure of the E2E orchestrator. I'm not going to describe it because I'm already very late. You are welcome to make question. Of course, Accordion is aiming at achieving several different kind of impacts and several innovation from the point of view of products, of software tools that we develop, and also of analysis recommendation about different processes for reaching specific goals that we have seen in Accordion. But again, I'm not going to be very long on these. And I just mentioned the fact that Accordion is one project under the umbrella of the Pervasive AI Laboratory, which is a collaboration between CNR and the University of Pisa, just like Charity and Teaching, which we mentioned before, and other projects which I don't mention. And that we are planning to have a third workshop sponsored by Accordion in conjunction with HPDC. Next year, HPDC 2023 is coming. Please look forward to participating in our workshop, because we think that the approach of Accordion has strong similarity and strong synergy with those of other projects, including Charity. I think that is all on my part.
Thank you very much, Massimo, for the interesting presentation and slides. So before to give the show to Ferran, I would like to ask if there are any questions for Massimo right now, or you can do them later if you have some question later on. But if there are now, we can have time for a couple.
Hi guys. I have one, if possible. That is, I mean, besides what is currently performed in Accordion, in more as perspective, I'd like to know Massimo opinion on that. So you know that there are many initiatives that have been financed by EU, EC, on the idea umbrella of over the concept of meta operating systems for the computer continuum, with the ambition of providing layers that already embeds some kind of services that instead Accordion is providing as a platform, a programming platform. And I'd like to hear your opinion on which kind of those services that we tend to assume part of this cloud edge environment should be, or to be moved at the level of a operating system or meta operating system, in your opinion?
But the point here should be to really understand what is the definition, what are the boundaries of a meta operating system. Of course, several of the services which you develop in Accordion are needed in order to get a hold of the whole set of resources in the platform. So in principle, they are also needed if you want to develop a meta operating system for the cloud. Conversely, some of the constraints and requirements which we see in Accordion as a requirement related to the fact that we have several multi-stakeholders group of resources inside the platform, so they need to secure interaction between them, actually would end up as something that is needed also in the MetaOS viewpoint, because of course you can assume that you have some degree of trust inside the meta operating system among the resources which are controlled by the meta operating system. But on the other hand, the actual physical interaction, physical access to these resources is by nature fragmented. So some way of providing security, privacy measures also inside the meta operating system would be needed. So my take is that most probably the set of services and resources which we developed with the viewpoint of realizing a platform made of separate systems joined together are actually the same kind of services which will be needed in a MetaOS operating system, in meta operating system viewpoint, with probably, with probably some different characterization due to the fact that maybe you have a degree of central trust in a MetaOS, but not necessarily, because it also depends on how you establish trust in these environments, maybe with distributed ledgers and not necessarily with a centralized approach. So my impression is that in that viewpoint, the Meta OS viewpoint, we will find that the services which developed are very closely matching those that they need. And maybe just a shift in perspective and minor changes may be enough in order to satisfy this kind of needs. But of course, that's my take. I have an opinion with of course, is worth as like the one or anyone else. And maybe we could try to understand also if the charity approach, which is not dissimilar from accordion, but has different emphasis on different characteristics, may be as well suited as well suited to be seen as something in the Meta OS field.
Thanks, Massimo.
Thank you.
Emanuele, we can listen.
Okay. Yes. Yes, I was muted. Yes. So thank you, Massimo. Thank you, Patrizia, for the question. I think we are slightly ahead of behind the schedule. So please, Ferran, the show is yours.
Your mic is off.
Thank you very much. I don't see not so much now Teams. Thank you very much, Emanuele, and also Massimo for presenting Accordion. But now let's do the focus on charity. What we want to do is like the how we have the cloud for holography and augmented reality, and how the Edge and the XR reality it's a new wave. And this is a joint presentation with Iago that is not able to join today. Charity Consortium has several partners. As you can see, we share some partners from Accordion, as you will notice, like CNR, Pharmacopio, Rama, Orbital Night. Oh, and basically, Plexus. And basically, we have also a large area of competence where we are able to have cloud infrastructure and technology providers, where we know about smart and autonomous orchestration, also about how to make information about the telcos, and also a lot of use cases, because this is a consortium where we have several use cases on holographic domain. As you can see, as application providers, we have like six partners that are able to provide applications to the charity platform. Basically, one of the main topic of charity is to have the immersive communications, where we have advanced media applications that allows you to have this immersive communication that it's getting normal in our life. And also, this has been reinforced after the pandemic, where all the people were at home and trying to have more personalized, more life experience with when we are starting to have communication with other people. And now it needs to have these social interactions if it's happening again. Of course, we have lessons learned from the last time. But the augmented and virtual reality is not a new concept, but it's a fascinating concept because we saw it in several films, the augmented reality and virtual reality. But now we are in a time that is getting more popular because of what we see, because we have now we have recent advance that means that we can make a significant progress in order to improve what is going on the holographic domain. Here we have the reality virtual continuum, where we have the real environment, basically what we have, and also we have the first layer of augmented reality, where we can put virtual objects inside of our real environment. What basically something that happened with the Pokemon Go. But Pokemon Go went to this augmented reality that you also can interact with the objects. And then at the end, we can have the virtual reality or the metaverse that Facebook or Meta, sorry, was creating. That is immersion in a fully digital environment. Why it is important? Because the market size that is expected is like that it is growing really fast and for the growth. And I think it's important to have a place in this market in order to create this application platform in order to be able to fulfill the market size and also not in terms of money, but also in order to get the revenue. Because if the technology doesn't evolve, we cannot get this market. And also we have a lot of potential markets. But instead of going one by one, that it can be done in multiple domains, let's focus what we have in charity use cases. Because we have this real-time holographic application where we can have an holographic concert, or we can have a holographic meeting where a person is recorded and then you can put the holographic on top of the chair, or the holographic assistants. But also, not only we can have immersive virtual training. It means we can train people that is in Stanford can train people in China about medical training without the need of taking a person flying to a different country and avoid problems. And also we can visit a museum based on using this immersive virtual training or virtual reality. Or at the end, we can have some kind of mixed reality interactive application where we have a cooperative gaming where we can interact with the reality, and also we can able to train in aviation domain in order to train the pilots are trained without to buy expensive devices. What are the challenges that has been addressed within charity project? From a network standpoint, XR services are we need use cases needs to create a new class of services because we need a very ultra low latency, extremely large bandwidth, and huge data processing power because it's a lot of information that we need to transmit through the network and also to process because it's not because in order in order to be able to work on this, we need to process them, compress and decompress in order to avoid to fulfill the requirements. And also, we want to satisfy the user experience. We don't want to have issues with the when you are experienced in the immersive virtual reality because you don't want to have a delay because the delays are annoying, and that's why we need to increase this user experience and couple with the hardware and devices that are currently in the market. But also, we need to consider the advantages of this 5G because at the end, we need to create this ultra low latency, but not only using fiber, but also the radio operations. What is the solution? Is we need to use the 5G and edge and cloud at some point because not everything can be done in the edge, but allows you to solve some bottlenecks that are if we are sending all the data to the cloud. And also the 5G allows you to have improved the speed and the latency and the agility and flexibility to transmit the data and reduce the latency between the users. Basically, a very broad of the architecture, is not the child architecture. It's an example about we have a physical network layer where we have some devices that are connected to that device, and they're connected through via different nodes, routers. And then if we want, but we need to add some data sharing and compute in order to be able to perform these use cases. Because if not, we are not fulfill all the requirements and challenges that we have from the beginning. And that's why it's the importance of the edge computing as a solver of this challenge, because the edge computing always allows you to process the data close to the user and then reduce the bandwidth that you need to transmit between data centers and sensors. But also, we need to we should decompose the applications into components and microservices in order to have an appropriate solution in order to deploy and manage our applications in order to have this hybrid edge cloud infrastructure. But then we need to, this importance needs the emergence of orchestration that is able to orchestrate these microservices into the cloud and the edge of the deployment of the edge infrastructure. And also we need to keep the interconnection of these dependencies because in order to doesn't violate the SLA constraints. How we focus the orchestration. Now let me explain how we should make give you some organic insights in order to fulfill these requirements and also how we can be able to address these challenges. One of them is the orchestration, but instead of making the orchestration, we want to do it via scheduling the user request, because at the end, the user request can be microservices, because the constrained nature of the edge networks pose by themselves very challenges, and then we need to manage the microservice workloads. It means how we distribute the workloads efficiently through all our edge cloud computing infrastructure. But also, we don't need only how we efficiently distribute, but also we need to take into account, not, as I said, not only the performance, but also the throughput and the latency constraints that these microservices contains, and also the communication between these microservices. What is a task scheduler? I will give you an overview, and basically we have a series of microservice queries where we have the task that we want to do. It's a completely generic, and some constraints like the latency and the performance of the quality of the experience or the quality of the service, and also the stream. What is the information that we will transmit into this microservice? And then it goes to a task scheduler, but where we can choose, depending how it is in our infrastructure, what is the best policies, like the process that always we send everything to the edge, or in order to have that all the compute nodes has the same balance, or the farthest, or the cheaper in terms of money, or at random. And then every model we can have different model variants, because depending of the cost, we will need to, depending on the task, we can have different processing time and load capacity, and also different performance. And then we can give what is the load if we are using this model, because maybe we can have different codecs for processing the images. And then, depending on the constraints, we can use a different codec while we are maintaining the quality of experience or the quality of the service. And then how we are making this working in order to use the most efficient way. That's why we propose an adaptive task scheduler using the reinforcement learning perspective, because at the end we want to have the incoming workload, and the agent, an agent that controls what is the best policy, monitors what is in the cloud edge infrastructure. According what is the current status of our infrastructure, we want to perform a scheduling policy, like the closest or the load balancer, any of these selected scheduling policy, and we take the microservice, and then we make the task scheduler. Why we are making a scheduling policy? Because we need to perform actions that are really fast, and we don't want to spend we want to select what are the best places where to select. And then when we have the task scheduler, now it starts the work of the orchestrator to make the deployment of the microservice. But at the end, we need to take solutions that are quite fast and avoid to have long waiting times using directly the orchestration. And then how we can learn this agent. At the end, we have an environment that is our infrastructure where we can measure how many microservices have been deployed, what is the latency, how many microservices has been rejected. And the idea is that we want to learn a reinforcement learning agent where we have these incoming workloads. We create a state of what is happening now based on both incoming and the infrastructure, and we perform an action. And then we are also selecting what is the best scheduler. And this scheduler will affect what is in the edge cloud infrastructure. And depending what if everything has been succeed, we improve the reward in order to train what was the decision of the agent. If we have a failure, also we are having a reward in order to train, in order to avoid that this action happens when this state happens, and that's why we need to modify this network in order to match the incoming, the state of the infrastructure with the action, and then we are learning through a simulator. But now we are able to transmit the jobs between the infrastructure. But also, as we said before, we need to know the connection between these microservices. We need to know how the traffic must be sent from one microservice to the other, and that's why we need a dynamically adapted network awareness services, because we need to have mechanisms and approaches and algorithms that are supporting this kind of connection through the network and are computational efficient services. That means that we need to have mechanisms that shows what is the status of the network, and also what is how it's the libraries and that we need to use on the models, but also the network. And that's why we need to have this dynamic multipath routing. It means we need to know what is the best way to transmit the packets in order to ensure the reliability and accuracy of the information that we transmit between microservices, in order to divide critical traffic or have some load balancing along several routes at the same time in order to avoid some problems. Because as I will show you now, we can have some attacks like the link flooding attack, because since we are having a network topology between all the infrastructure, and also not only among the old infrastructure, but also among the microservices, we can have some people, some adversaries can attack these links. It means that they can inject some low volume flows to the normal traffic between these microservices, and then we can have some issues and delays and increase the latency of these links, because they know what is the topology of the network, and then with the quality of the experience and the quality of the service will degenerate. And that's why we want to avoid, and that's why we propose a EqualNet that tries to obfuscate what is the topology of the network in order to avoid these links, and then the traffic routing mechanisms can work efficiently without the need of taking into consideration these attacks. And that's basically what EqualNet offers. What we are doing is like we equalizing the tracing flow distribution between the nodes and the links, because then if you have everything is equalized, it means they don't know what is going on through the links and what are the most popular nodes. And then we create some virtual nodes to avoid such analysis, to know what is the popular node. And then we always monitor how much topology information is leaked. And then we can dynamically refuscate the network, because the traffic can change over time. And also we know that as more information the person receives about the traffic, can leverage what is happening on the network topology. But I think, and then with this threshold allows you to keep a high degree of security about the network topology, and then fulfill the traffic has not some issues. But also there is another issue when we are trying to work on the edge, is the data sharing. because at the end, what we mentioned before is that the edge computing moves data and computation closer to the user, to the client. But at the end, these edge devices has not a large device storage, and that's why when we need to know what is the best way to make the sharing of the data between these edge clients and also edge devices. And one possible solution that we investigate is the analysis, the design, and the evaluation of the IPFS. But what is the IPFS in words? It stands for the Interplanetary Unified System. It's basically the centralized storage and the delivery network in order to share the data. It's operational since 2015, but the idea is that you provide your data, it's in a node, and if you want to some person request this data, make the request, and the algorithm is able to know where is the data stored and retrieve the data to the requester. And that's basically what we are investigating in order to use it for the edge devices. And basically, now for conclude the charity part, the charity use cases are basically, as I said, a key sample of multiple application patterns that we can have in the orographic domain, and also what charity architecture technology will be able to develop a complete framework for this immersive communication. And also, we are able to make a lot of innovation architectures, cloud architectures, in order to exploit the edge solutions, computing and network continuum with autonomous orchestration, application-driven interfacing, and this is compatible with the infrastructure vendors because at the end is an abstraction layer. And finally, the future network XR interaction will enhance the effectiveness and reliability of this remote correlation, improving all human process in order to improve what happened during the last 2 years. And thank you very much for your time. Before ending, I want to advertise that in 3 weeks, there will be a joint webinar with charity and physics. And on November 29th, it will happen. Don't miss it. Thank you very much.
Emanuele, you are muted.
Yes, sorry for that. I have some problem with the microphone button. Anyway, thank you very much, Ferran, for interesting topics and the slides and your presentation. You've been very fast, so we have some time for additional questions. I see one raised hand. Yes, Kostas, please go ahead.
That's me, yeah. Hi, Ferran. Thanks for the presentation. A question I'd like to ask is related to the kind of connectivity that you are assuming that exists between the various charity, let's say, computing nodes. Do you assume that there is a leased lines or something like that, or do you also assume that there might be the public internet, whatever infrastructure you need to use the public internet to connect your computational nodes? I mean, do you also consider 5G connectivity between the nodes or things like that, or do you think of different types of resource and network resources that are more dedicated to connecting those two nodes, like leased lines and things like that?
I think if we want to have this ultra low latency, and also if we want to have this, if we are tackling the problem of high bandwidth, I think the 5G is not the best case, and that's why maybe we need to have these line fibers between computation nodes in order to have to be able to fulfill these requirements in the orographic domain. Because, for instance, and there's a simple example, when we are making deep learning, most of the computer servers goes to the PCI Express, and NVIDIA create a workstation that, in order to make fast inference with large models, what they are making is they create a protocol that communicates between GPUs instead of going to the PCI Express in order to improve the bandwidth. That's why we need to have a dedicated cable or fiber that connects the edge or different communication protocols, because at the end we don't have control on what's happening between one infrastructure point and the other one.
I see. Yes, great, thanks. So that definitely makes sense then. There might be also, solutions that are commercially available. Recently, at least, they became commercially available that you might want to have a look at, like, I don't know, the AWS local zones and things like that. So it might be, it might be relevant. So I'm just proposing that in case you're interested.
Thanks. No, we are interested, but yes, but we can have it offline if you want.
Yeah, sure. Yes. Thank you.
Okay, thank you. Kostas, any other questions? Okay. Thank you very much to the speakers then. Thank you, Massimo. Thank you, Ferran, for your presentation. The seminar was very interesting, and I hope this is one of several other joint seminar between Accordion and Charity, perhaps even on some on the same topic, and to see how the two projects, even though similar, they approach to a solution, to a problem, perhaps with different solutions. So and also maybe this is an occasion that I hope made the collaboration between the two projects stronger, and I hope this kind of events and ideas between two projects would continue in the future. I also see connected Uwe Erdog, and who is the coordinator of Accordion, of Charity. So perhaps I don't know if Uwe, if you want to say something, or perhaps Tariq Taleb, who is the technical coordinator.
Yeah. Thank you, Emmanuel. I mean, as I told you and as I wrote to you in my email some days ago, definitely such kind of collaboration is highly welcome. And somehow I'm actually involved in Accordion as Oulu University, and also involved in Charity as ICT official. So I'm actually in favor of the collaboration between the two projects. Yeah.
Great, thank you.
And definitely this webinar was something which was really good in that sense.
Okay, can you hear me now?
Yes, Uwe, please go ahead.
Yeah. I just want to confirm what Tariq just said. So yeah, I think it would be very beneficial if we could intensify our cooperation, as the topics we are working on is really close. Huh? So I know we already have some good interaction also thanks to the overlap of many of the partners in both consortia. So I think this is good what we have started, but indeed we should look at how we could further intensify, and organizing further such events is certainly one part, one thing that we could do. But I suggest that we also have a discussion on what additional actions we could do in order to really benefit from each other, because I think it really makes sense as we are working on so similar topics and with a lot of partners on both sides.
Yes, I agree, and we will do that. So we are in time. Thank you very much again to the speakers, to the attendees, and I think we can close the meeting. See you to the next one, and thank you again.
Thank you.
Thank you very
Bye.
much.
Thank you.
Thank you.
Thank you and goodbye.
Bye.
Thank you.